Hello everyone, welcome back to my YouTube channel. Today I'll be discussing grade 10 chemistry. The lesson is chemical equations and reactions. From this lesson I have taken few questions. So let us look at the question 1. The question is a white salt on heating. Okay, the energy used here is heating, decomposes to give brown fumes and a residue is left behind. Okay, so you need to name the salt and write the equation for the decomposition reactions. Now, how do we know that the which compound is white in color? Because a lot of compounds are available in our chemistry, which is white in color. So the clue you need to remember in this question is brown fumes. Which gas is brown in color? That is nitrogen dioxide. What is the formula for nitrogen dioxide? Nitrogen is N and there are two oxygen atoms, that's why dioxide, so it is NO2. Okay, so the brown fumes obtained is nitrogen dioxide. Now, which compound on heating decomposes to give this brown fume? That is lead nitrate. Nitrate. So which one decomposes to give your nitrogen gas? Okay, so what is the formula of lead nitrate? Lead symbol is Pb and nitrate symbol is NO3. Okay, and what is the valency of lead? That is 2 and NO3 valency is 1, and when you crisscross the valency you will get the formula Pb NO3 twice. This is lead nitrate. Pb NO3 twice. Okay, and this compound is white in color, so your white salt is lead nitrate. Okay, now this is on heating. It produces brown fumes. So what is a brown fume? That is nitrogen dioxide. Okay, so NO2, nitrogen dioxide, and it is a gas, so it liberates out. This is brown in color, and you will get two more products, that is lead with oxygen. So PbO, lead oxide, it is red in color, and one more product is oxygen gas. Okay, so these are the three products obtained when lead nitrate is heating. Fine. So now we got the compounds and we got a chemical equation also. So the next thing is we need to balance the chemical reactions. When you look at the product side and reactant side, you can understand that the atoms are not balanced yet. So how do we balance this reaction? So in any chemical reaction, for balancing, it is better to start with either hydrogen or oxygen. Okay. So when I'm looking at the reactant side, I'm taking oxygen atoms number now. So how many oxygen atoms are there on the reactant side? So 3 into 2. So there are 6 oxygen atoms. Now, what about nitrogen atom on the reactant side? Only 1. And what about lead? It is 1. Okay. So these are the number of atoms given in the reactant side. Now, look at the number of atoms on the product side. Okay. So on the product side we have nitrogen, only 1, and oxygen it is 2, then 1 on the lead oxide side and 2 on the oxygen side. So total it will be 4. 2 plus 1 plus 2, that is 5 oxygen atom. And what about lead atom? Lead actually only 1. Okay. So these are the number of atoms present on the reactant side and the product side. How do we balance this chemical equation? Okay, let me start with the oxygen atoms now. There are 6 oxygen atoms on the reactant side, but there are 5 oxygen atoms on the product side. It is not balanced. So we can start with the oxygen atoms. How can we make 5 into 6? That will be little difficult because we are multiplying the number of atoms. So if I am trying to multiply this with the 2, it will be getting 10 atoms. 5 into 2, that will become 10. But here it is 6 only. So I cannot make this into 10 by multiplying with the 2. So I'm just putting multiplying with the 2 over here, then it will be 12 atoms. Okay, so let me try. I'm putting 2 over here, which means that the number of atoms on the oxygen on the reactant side will be 12 now. How can we make our oxygen atom on the right hand side into 12? Okay, so there are two lead atoms over here, so I'm just trying to balance 2 with lead. So there are 2 lead. Now oxygen will be here, 2 oxygen, and O2 side it is 2, so 2 plus 2 it is 4. So there are 4 oxygen now, and the remaining we can put on the NO2 side. So we need 8 more oxygen atoms. I am putting 4 over here. So 4 into 2 it is 8. 8 plus 2 10. 10 plus 2 12 oxygen atoms. So total number of oxygen now it is balanced. Okay. So now on the product side, oxygen atoms are 12. So that is balanced already. And what about lead? Lead is 2 on both sides. Okay. Now it is balanced. And what about nitrogen? Nitrogen it is 2. And this 2 into 2 it is 4 on the reactant side. On the product side it is also 4 nitrogen atom, which means the reaction is already balanced. So in this question we already answered 2 questions now. Name the salt, that is lead nitrate, and write the equation for the decomposition reaction. That also we wrote. And what type of reaction is this? That is thermal decomposition reactions. And when you heat lead nitrate, brown fumes of nitrogen dioxide is obtained, and a red color substance also obtained along with this product, that is lead oxide. Okay, now let us move to the next question. A solution of X is used for whitewashing. Okay, a solution of substance X is used for whitewashing. What is the substance X? State the chemical reaction of X with the water. So which compound is used for whitewashing? Whitewashing we are mainly using slaked lime. Okay, slaked lime means it is calcium hydroxide, CaOH twice. Calcium hydroxide. How do we get calcium hydroxide? Calcium hydroxide is obtained from calcium oxide. So the substance X is calcium oxide. Calcium oxide, that is your substance X. Okay. Calcium oxide. So what is the formula for calcium oxide? Calcium symbol is Ca, and oxide we write O. And the calcium valency is 2, and that of oxygen also 2. That can be cancelled each other. So formula will be calcium oxide is CaO. Okay. This when reacts with water, calcium hydroxide is obtained. So this reaction is actually a highly exothermic reaction, which means a large amount of heat is liberated. Okay, and this calcium hydroxide is used for the whitewashing of walls. Now, second part of the question is, why does the color of copper sulfate solution change when an iron nail is dipped in it? So copper sulfate solution, the formula is CuSO4. When you dip iron nail, its color is changing because copper sulfate is blue in color, and you will get the product as FeSO4 plus copper. The blue color will change into green color. So why does this color is changing? What is your answer? This kind of reaction we call it as displacement reaction. So which are the two metals involved in this reaction? One is Fe, the second metal is Cu, that is copper. And when you look at the reactivity series, iron is more reactive than copper. That's why iron displaces copper from the copper sulfate solution. So you will get the product FeSO4 and copper. Okay. So why does the color of copper sulfate solution change when an iron nail is dipped in it? This is because iron is more reactive than copper, and iron displaces copper from copper sulfate solution. That's why the blue color of the copper sulfate solution changes into green color FeSO4. Now we can try one more question. That's a higher order thinking skill question. A magnesium ribbon is burnt in oxygen. Okay. Magnesium ribbon is burnt in oxygen, Mg plus O2, to give a white compound X. So what is this white compound now? So you already know that is magnesium oxide, MgO, by the emission of light. If the burning ribbon is now placed in an atmosphere of nitrogen, it continues to burn and forms a compound Y. Okay. Now magnesium, when it reacts with the nitrogen, what is the product obtained? That is the question. So this is the first compound obtained is X. Okay. And this reaction is not balanced. How do we balance? Oxygen on the reactant side is 2. So product side we need to make it as 2 by putting 2 on the MgO side. Now 2 MgO, you can put 2 on the reactant side. Now the reaction is balanced. So magnesium ribbon, when you burn in oxygen, the product obtained is a white compound. This is white in color. Okay. And the name is magnesium oxide. Now if the burning ribbon is now placed in atmosphere of nitrogen gas, what is the product obtained? That is Y. Okay. Now, so when a substance burns in nitrogen, the product obtained will be its nitride. So magnesium burns in nitrogen, you will get magnesium nitride. Magnesium nitride. Okay. So magnesium formula will be Mg, and a nitrogen. Nitride means it's nitrogen only. So nitrogen formula is N. And the magnesium valence is 2 and that of nitrogen is 3. So when you crisscross, the formula will be Mg3N2. Okay. Mg3N2. This is magnesium nitride. That is the compound Y. Now we got the compound X and compound Y. Compound Y is magnesium nitride. Fine. Now write a balanced chemical equation when X is dissolved in water. X is dissolved in water. So what is your X? X is magnesium oxide. So what you will get when magnesium oxide is dissolved in water? Magnesium oxide, MgO, MgO, when dissolved in water, H2O. This is a metal oxide. Metal oxide, when dissolved in water, metal hydroxides are formed. Metal hydroxides. Okay. So product will be Mg hydroxide formula is OH. And you know, magnesium valence is 2, so you need to write twice over here. And OH valence is 1. Okay, so formula of metal hydroxide, this magnesium hydroxide is MgOH twice. This is magnesium hydroxide. Magnesium hydroxide. Okay. Now, when magnesium burns in air, you will get magnesium oxide, which is white in color, along with light. And burning magnesium continues to burn. If you are allowing to burn in an atmosphere of nitrogen, you will get magnesium nitride, that is the Y product. And when magnesium oxide dissolved in water, magnesium hydroxide is obtained.